Thanks, Derek. It's a pleasure to introduce Kos Coronaios to you. I can't actually remember how long ago it was that I met you. I think it might have been at the Southern Star party near Bonnievale. Yeah, well, I knew about him. He was very active from an ASSA perspective. He was, in fact, I think the only person that I know that was simultaneously a section director of two sections, Educational Outreach, and the other one was Astrophotography, I think. Observing, that's right. You were the observing director. And he's also one of the only people that I know that got President's Awards in the same year for both of those two. It was about 7, 8 years ago. Okay, so Kos has been active in astronomy for many, many years. I remember when he lived in Polokwane, one of the statistics that tipped the scales in favor of President's Award was that he had basically, with the aid, or maybe I should say his wife, with a little bit of help from Kos, actually reached more than 1,200 people during a year through the various activities they had in Polokwane. So he's been very active, and I think the talk that he's going to share with us now is not just astrophotography. I also thought you were going to go back to basics and share your life as an astronomer. Looking forward to your talk, Kos, and welcome. We're glad to have you as our guest speaker.
Thank you, Peter. Welcome, everyone, and thank you once again for inviting me. I think the last time I was here was about 4 years ago, and I did a presentation on interest comets. So yes, thank you, and then welcome to everybody else who's joined us on Zoom. I saw a couple of names there: Billy, Chris Trichardt. Who else was there? Yeah. Oh, Ed. Yes, hi, Ed. So welcome to everybody else. Okay, just thank you again, Pierre, for those kind words. I have been involved with ASSA for a long time. I think it's close to four decades. And it was about 10 years ago that that council agreed to a proposal of restructuring the website and also appointing an observing director. As Pierre said, at that time, I was pretty active in both observing and outreach. And I was pretty much honored to be nominated, and I accepted the invitation. Okay. Done. And what followed was some of the most rewarding moments in my astronomy career. All right, so I was honored to be nominated, and I accepted the position, and it was quite an interesting journey after that. Just a couple of slides of the first one of observing, and then the outreach that we were involved in. Okay, and then at that time of the period, social media was starting to kickstart. I was the chairman of the Serpensburg Astronomy Club, and I basically started the club's Facebook page, and it was it turned to be quite a popular platform. And from there, it was logical that we would look at, as I said earlier, on restructuring the website. Aki did a very, very good job with that. I did assist there where I could, but the Facebook page was sort of my baby, and council approved that ASSA goes off and starts a FB page. There was a little bit of hesitancy at first, but it has proved itself to be quite a useful tool in marketing astronomy and marketing ASSA. Just going back to the Serpensburg Astronomy Club page, we were quite active on the page, from newsletters to sharing information with Johannesburg Planetarium, with SASTA. So it really was quite a useful tool. At the moment, due to other commitments, I have relinquished both my roles as observing director and outreach officer. But I'm still involved in the social media as a liaison officer on Facebook, which I'm quite, should I say, it's not, I'm not as active as I used to be. And I think one of the reasons is our weather down here. Although the astronomy events remain the, although the astronomy events remain constant through the year, we have certain events. The actual outreach side from my location in Pearly Beach and the weather, we are hampered quite a lot. But the slide that I've got up there is actually quite interesting. So the first year that we, especially for us in the Western Cape and Cape Town, the first year we had just over 50 likes on the page. This year, a couple of weeks ago, when I drew the stats, we had 5,000 followers, and out of those 5,000 followers, most of the hits we get are from Cape Town or Western Cape. Initially, we started with 51 hits about 10 years ago, and it was 869 a couple of weeks ago, which is actually quite nice for our part of the world. Certainly more than Gauteng, more than Joburg or Pretoria, and it's quite interesting that we have quite a popular, or quite a strong following on Facebook from the Western Cape, from Cape Town. All right. Astrophotography, I'm not too sure how many of you practice astrophotography, but it's actually quite, every time you go out and take a picture of the sun or the moon or a landscape shot with stars behind it, you can do this when you're camping, when you're caravanning, when you partaking in the outdoors. So it's not just having the equipment to do that. You can actually do it with a standard camera, standard tripod, a shutter release. But if you want to really get serious into astrophotography, it's quite an expensive hobby, very expensive. The learning curve is huge to be able to take decent shots like that galaxy there. But you don't need expensive equipment. You don't need a lot of time to spend to take a very, very basic shot like that. That was the first ever picture that I took with a digital camera. It was my dad's. He bought a camera. I still had a Canon, a single lens reflex, a very, very good camera. But for me to be able to take a picture like that, develop it, print it, and actually show it within the space of a few seconds was unheard of. All of a sudden, I could do this. It was unbelievable to be able to just point a digital camera at the sky and then end up with a picture like that. So just yeah. But that was quite a turning point in my astronomy. I could, whenever we spoke about certain events or looked at certain objects, I could actually take a picture and show people what it looked like either through a telescope or just with a naked eye. It was really a turning point. And just to give you an example of how over the years it has progressed, that same shot of the Milky Way, this is something similar. And as you can see, it's much, much better. There's no star trails, not too fuzzy. There's a bit more clarity to it. So you can see how the images have progressed from that first one. I'm going to go back just to show you to that fuzzy. The stars are all blobby and they're round, and they're not that star-like points that they should be. Whereas opposed to the next couple of pictures, quite a marked difference. The instant gratification of being able to manipulate an image pretty much shortly after you've taken it has really, really changed the face of astronomy, amateur astronomy, and outreach. We can have live feeds now of what the telescope is seeing, what camera is seeing, and you can project that onto a screen. And instead of having a queue of hundreds of people at the telescope waiting to get a glimpse of Jupiter, you can actually project it on a big screen, and there's a marked difference in how many people you can reach. I'm still a purist. I prefer the view through a telescope, but it's just quite nice to be able to see what the telescope is seeing on a screen. All right, so we're going to talk a little bit about equipment and basic equipment, just to practice a little bit of astrophotography without spending too much money. And first up has to be a tripod. And what you're seeing up there is what you shouldn't use. Definitely not. You won't be able to. A DSLR camera with a lens, even if it's a short focal length, will not be very steady on a tripod like that. You need to look at something a little bit more elaborate, a little bit more sturdier. And as with telescopes and mounts, the big thing with a telescope is the mount. You could have a very poor telescope on a reasonably good mount, and it'll be 100 times better than having it the other way around. Same thing applies with taking pictures. Your tripod, you have to have a steady mount. It's imperative. So that's your mount. Another piece of equipment that's very crucial is a shutter release cable. That's an old style shutter release cable for those of you that still have old cameras. I do still have that. Yeah, I still do have as well. And then of course, something that is not necessary, but quite useful to have is an intervalometer. It can do so many more. So there's so many more applications than just the basic bulb setting or shutter release. You can set when to start taking the pictures. You can set the time between pictures. You can set the duration of the images, the duration of the exposure. You can take as many as 999 shots before you have to reset it, which is quite a lot. So I do use one. I must admit, I don't use it too often. I don't. With the astrophotography, I do either via telescope or with a camera and a tripod. I don't spend hours taking light frames or darks or flats or bars. I limit that to about 10 to 20 minutes for the basic reason that I don't practice astrophotography like the big boys do. So all the images that our South African observers and astrophotographers do they've spent hours integrating those images and collecting data. I don't do that. I look at their pictures and say, wow. A lot of the cameras on the market at the moment, I know Canon have got I think it's a 5D Mark IV or something. They have a built-in intervalometer that's quite handy. I think Nikon also does one. But that's, yeah, if you can get your hands on one, it's ideal. The big thing with both shutter release and intervalometers is that it excludes camera shake from your equation, which is a big point. You don't want to be pressing the shutter and having any sort of shake or camera shake that'll spoil the shot. To set your self timer on the camera to give you a 2 or 3 second delay is possible, but it just takes so much time to then capture one shot. Then you've got to wait 2 or 3 seconds for the next shot, and then there's always a chance you're going to bump something. So yeah, shutter release and intervalometers are the way to go. And then of course your cameras, anything from a single lens reflex to a digital camera. Your compact cameras are also pretty useful. The compact cameras today are really advanced cameras. They, I think if memory stands me right, I think a compact camera has got more megapixels than my Canon 30 or 60D. That's 10 years old, and they have quite a lot of advanced settings. Some of the settings that you do that your camera has to have is a bulb setting. It allows you to open up the shutter for as many seconds as you want, especially for those long exposures where you have a trail of stars. You need a bulb setting to do that. you need to be able to set your shutter speed from 1 to 30 seconds. So you'll see that most of the images that I'll show you have been in the range from 1 second exposures to about 30 seconds on a tripod, that is. So you need to be able to control the camera and use those settings. You need to be able to expand the ISO, which is basically what I've got there. I think it's a Canon 60 or 30D. It can go up to 25,600, which is quite high. But you do need that expanded ISO. Another thing you have to have, especially if you're looking at compact cameras, is you need to be able to set the focus either to infinity, or you need to turn it off and actually set it manually. The infinity focus on a camera, I don't actually trust. If you are planning on doing some astrophotography, please take a couple of test shots at infinity and see what comes out, to be able to see whether that image is actually clear or not, before you start taking a whole lot of 200-300 shots and half of them are out of focus. On a SLR or a DSLR, you have that option quite easily to turn the lens onto manual, and then you can actually focus manually on a star and see that you're getting a pinpoint star. Talking about lenses, we're looking at short focal length lenses, and a good number is anything from about 10 mil up to about 135 mil. And then your telephoto lenses, anything from 200 mil to, I use a 300 mil, sometimes a 400 mil. Regarding lenses, the big thing there is your budget. If you can afford a fast lens, that's the way to go. So we're looking, let's talk about a telephoto lens, a 200 or a 300 mil lens. If you can afford a lens that'll open up, have an f-stop of about 2.8, that's reasonably fast. Otherwise, they normally come out at f4, f5.6. And that's a little bit slower. It just means you're not collecting as much light. Your shorter focal lens, shorter focal length lenses, 1.4, 1.8 is a good f-stop. And I'll talk a little bit more about those wide apertures and the quality of the print that comes out when you use lenses, wide angle or telephoto at that maximum aperture. I'm not going to go too deeply into explaining about apertures. I presume everybody is aware aperture is the diaphragm in the lens that closes and opens and lets in X amount of light depending on the setting. Okay, then some other equipment that's quite handy, and that's not to play with, although they can be quite a lot of fun. A laser pointer. I'll touch at a later point in the presentation of what we can use it for. But if you do have one, it's quite handy. Why is it going backwards? Duct tape, ladies and gents. Duct tape is one of the most important items in anybody's toolbox or carry pack or whatever. I will explain why I say that again at a later stage. Another very cool piece of equipment, and you can download that off the internet, is a Batonov mask, and this is for I think it's an 8-inch that I made. You can download it from the website to any size that you want, so you can put onto a 200 mil, onto a 300 mil telephoto lens. It's quite crucial to be able to focus and make sure that you have achieved 100% focus. It's such a, not a waste, but after a half an hour in our session, if you've got to throw half your photos away, or even most of them away, because you're just a little bit out of focus, it's quite sad. So that Batonov mask really helps you to focus crucially. You can see what it's done to that star. What you need is a reasonably bright star. You zoom into the star, tweak the focus, and you get refraction spikes. And if they are concentric and in the middle, they are perfectly in focus. You can't go wrong with that. The nice thing about some of the cameras as well, some of the digital cameras, especially the one that I use, it's a 60D that I mainly use. The viewfinder can, or the screen can tilt. So you don't have to get down on your knees to have a look at that star that's right up there to be able to focus. You can just tilt the screen, put a mask on, or zoom that star in and then focus without straining your neck or breaking your back, especially at my age. All right. Moving along. Okay, just some of the things that you need to have in place when you start. Okay, let's just skip the target for a sec, because the target, basically, whatever you're going to shoot, whether it's a landscape shot or the Milky Way or a nebula, it's gonna tell you what camera, if you've got a choice of cameras, or what lens to pick. So let's just progress down to the focusing. You have to set the focus onto manual, and as I explained, please double check that you are. Just take a test shot and double check that you are focused correctly. The duct tape is very, very handy. You just, once you've got that lens focused properly, duct tape, and you can then move the camera around. And if you perhaps manage to touch the lens by mistake, you will not lose focus. Because again, I stress that focusing is so crucial to this game. White balance. Okay, I normally set that at auto. Just let the default auto setting. I've never ever played around with it. I've never changed it. It seems to have worked. So I leave that at AWB, just auto white balance. And then the big thing, do you shoot in JPEG or do you shoot RAW? And there's really, again, as with a decent tripod, you have to shoot in RAW. It takes a lot more, it uses a lot more data. You probably need more space on your hard drive or your laptop, but the amount of data that a RAW image collects as opposed to a JPEG is worth shooting at RAW. You have to at least try it. If you're not sure, if you don't think that there's a difference, the data in a RAW image will collect anything from 15 megs or 15 gigs to a JPEG of 1, 2, 3 gigs. So it really is crucial that you also shoot in RAW. And then we get to ISO and f-stop. Your ISO, again, depending on the target, which we'll go through just now, when you're shooting the Milky Way, it'll be slightly different settings. As will your f-stop. You'll notice there that I haven't touched on exposure time, which is probably the most crucial of all your settings. Okay, so if you look up there, look up on the screen, you'll see that there's a rule of 500 rules. Some people refer to it as the 600 rule. And if you divide your focal length by 500, you get a figure that basically tells you how long your exposure time should be or can be. That's a maximum time that it can be before you start getting star trails. Okay, so if you look at a 300 mm lens, 1.6 seconds, and if you expose for 2 seconds, you will get a star that's not pinpoint. You'll get a slight elongated blob. It's nothing serious. So a lot of the astrophotography I do, especially if it's not on a mount, I'll push that 300 or that 200 mm lens to 2 seconds, 3 seconds, and I'm quite happy with what I get because I'm looking at a comet. So that's the crucial point in that shot. I'm not too worried about the stars. I want to get more detail from the comet, of the comet, as opposed to the star. So for me, it's not too crucial. But you can see the difference there of shooting with a wide angle lens, 21 seconds. Again, I push it to 30 seconds. I'm quite happy with the results that I get at 30 seconds. And a telephoto lens, 300, 400 mm, you're looking at 1 second and you're going to get star trails. Okay, so it just gives you an idea of what short exposure time you had with a with a decent birding lens, like a 400 or 500 mm lens that you're going to take pictures of birds with, or something that's reasonably far away. If you point that at the stars, you are going to get a streak after 1 second, basically a star trail. Another big thing that you need to do with exposure time is, once you have taken a series of shots, and I'm specifically now talking about something like a nebula or a cluster. Once you've taken, say, 20, 30 or 100 shots, you have to, and that's where the laser pointer comes in, you have to move your tripod back to the original focal or focus point. Okay? Because any programs that you're going to use to stack those pictures will allow for that, but it makes it easier if you help it along. So that movement, you need to just realign the camera. Laser pointer is ideal because you can point exactly where it was before and then just move your camera. The duct tape, again, helps in setting the laser pointer to the tripod or to the camera, and also keeping the laser pointer switched on, because you don't forget, you have to press that button on the laser pointer and keep your finger on the button. As soon as you release it, the laser point, there's no more laser. And while you're trying to manipulate the camera or binoculars just to make sure that you've got the right target, it's just so much easier. Just duct tape, boom, and Bob's your uncle. All right, so we're going to go to targets. And two of the targets, of course, have to be the brightest objects in the sky, the sun and the moon. And I'm going to start off with the sun, and of course, I'm going to put that warning up. Please read it. That is crucial. We're going to start off targets with the sun, and the fact that you don't point any optics at the sun, binoculars, cameras, anything, unless you have the correct tools, the correct filters, because you can really damage your eyesight. A lot of the pictures that you're going to see of deep sky objects, sun, moon, were taken with a 200 mm lens or a 300 mm lens, and all of them have been quite drastically cropped to get that close view. All right, so let's look at, I'm going to not say too much about the sun. If you Google solar filters, you can get a whole range of filters that you can use for a telephoto lens that you can adapt and cover it. It's doable. I've done that on quite a few occasions on my 300 mm lens. It works quite well, but please make sure the source is 100% foolproof and you're doing the correct thing, okay? Because it can get quite dangerous. But we're going to move on and look at the moon, especially a full moon. I mean, it's a nice, easy target, reasonably bright, and you will need at least 2, 3, 4, 500 mm lens to capture that image. With a moon, you need to be shooting. If we go to ISO and f-stops, you need to be shooting at a very slow ISO. So 100 is actually a very good number. You've got a lot of light reaching that lens, reaching that sensor, but you don't need to generate extra light by pushing the ISO to a higher level. And then also with the full moon, you need to stop your f-stop by at least, or underexposed by at least 2 stops. Otherwise, it just whites. You just got too much light coming through. So this particular shot was taken with a 300 mm lens. As you can see, the exposure time was 850th of a second, which is quite fast at a very slow ISO of 100. It's been post-processed. You can see there's a bit of sharpening there. Some of the darker regions and the lighter regions, or the contrast has been changed slightly, and I'll explain how we do that as we move along. But just a different selection of moon shots. Can we get rid of the bottom? There we go. I probably won't be able to go to the next slide. All right, so that's again a shot of the moon, a wide field of view, a wider field of view with a 300mm lens. But you can see the difference now in the ISO, push it right up to 2,500. That's pretty fast, and 850th of a second. All you'll have there is just a dark print. Okay, so that's much slower. It's six of a second. And the big difference with the lighting there is that you're looking at a crescent moon. So it's not a full moon, so there's not that much light reaching the center. So you do need to push the ISO, and you also need to expose for quite a lot longer. I mean, that's nearly one second. Again, something similar shot with the moons of Jupiter that can be seen. Again, very, very high ISO. It's a 300mm lens, and that particular lens only goes to f4, so it's as wide open as it can, and that's 1/4 of a second. Slightly, or should I say, about the same as the previous shot, but the ISO has been doubled. Okay, and that was basically just to be able to get the moons of Jupiter, which are visible down the bottom there. Again, just a nice crescent moon, probably about a day and a half old. If you look at that ISO again, it's very, very, very slow, and that helped in getting the colors, the sunset colors coming through. With the faster ISO, you'll tend to lose that. So that's another reason why you try to keep your ISO slower, just short of a second exposure. And again, you can't push it for too long, otherwise that moon will start getting the crescent that you see won't be as sharp as it is there, because there is movement, of course, and it'll become fuzzy. So you've also got to just play around and see what works. And the nice thing about the digital side is you can actually see the picture straight away. You can zoom in and say, okay, that's in focus, or oops, that's blurry, either camera shake or too slow shutter speed or whatever, and you can adjust for it. Those two pictures, again, shot with a 300mm lens and heavily cropped, just to give you the difference in sizes between the largest and the smallest moons. That was in 2014. There's another shot of first quarter moon, and that's Saturn on the left-hand side, the up in the left-hand corner. Half a second at a very, very fast ISO, and you can see you get a lot of graininess there, and that's basically a byproduct of using a very, very fast ISO. All these pictures have had no dark frames subtracted, no noise reduction applications, either post image or done with the camera. Okay, they're just straightforward, pure shots with a little bit of manipulation afterwards, just to bring out a little bit more contrast. But as far as the artifacts due to the graininess due to shooting at a very fast ISO or high ISO, I haven't compensated on these images at all. Okay, so there are cameras, we'll get to it at a later stage, there are cameras where you can take a shot and then at the same time also take a dark shot, and it'll subtract the dark frame from the light frame and make it. I have not in all these years, I have not found it that there's too much difference between the two. So I don't do it. For me, it's a waste of time. So if I take a 1 second shot, 20, 30 1 second shots, and I'm going to allow another 20 or 30 1 second shots that the camera is going to take between each shot. So it becomes time consuming. If I'm going to do any processing of it like that, I will do it afterwards, and I'll take a few dark frames and subtract them myself. Again, just a shot of the moon, also with a 300mm lens. All right, then we get to nebula. Okay, this is one time where you can play around with the aperture. Sorry, what I didn't say with those previous shots. So a lot of those moon shots were all done at wide open apertures, f4 with a 300mm or f2.8 with a 200mm. Experiment with your lens and your camera. Sometimes with a bright object like the moon, it's actually better to stop it down by at least one stop. So take a picture and see if there's a marked difference. You might find with a bright object like the moon, it actually is better, depending on the lens, to just stop it by one stop. It'll give you a much better image as opposed to a fully wide open aperture. So over here, what I've done, I shot, it's often Beta Centauri. I wasn't interested in the stars. Okay, they weren't the focal point. I was trying to get that dark dewdate on the left-hand side. And you can see it's just a stack of 22 light frames. You can get it coming out quite easily just after 22 shots. And there were 1 second shots at quite a fast ISO. But what I did there was I stopped the lens, I think it was a 300mm lens, I stopped it by one stop. And what it did was it brought out those diffraction spikes on the 2 stars. So that became more of a focal point as opposed to that dark dewdate over there. So with stars, if you want nice blobs or round blobs, open the lens fully wide open, and you'll see a couple of images further on. You'll just get round stars or pinpoint stars. As soon as you shut the lens by 1 or 2 stops, you'll get those stars. It's not an artifact that I've done after the shot. It's actually just taken like that. I haven't changed anything. What I've done there is just basically stack 22 images of 1 second exposure times. Okay. The same thing will apply if you have a wide angle lens, an 18, 50, even 135. If you stop it by 2 or 3 stops, you will get that same effect with the stars. It's just a bit more difficult to see because you've got a wider field of view. Here you haven't. You've got a nice, in that 300mm lens will give you a field of view of about 5.5 degrees by 3.5, which in a telescope's field of view is quite large, but for all intents and purposes, for our explanation here, it's actually quite a wideish field of view. There's another shot of that lagoon and Typhon Nebula. Also about a stack of 30-second shots. For some other reason, I didn't annotate that one, I don't know why, but that was taken with a 200mm lens. And if you look carefully, well, it was shot at 2.8. If you look carefully, those stars are just blobs, as opposed to the previous image where there were spikes. And that's the difference with shooting with a wide open aperture or closing it down by one stop. You'll get pinpoint stars. Same with this shot at 2.8. It's quite a few more images that were stacked, 120 of them. And again, the aperture is wide open aperture, but all the ISO speeds are all high. They have to. These are, even though these objects are quite bright, you still have to collect quite a lot of light, and by pushing that ISO, it certainly helps doing that. You're going to see quite a few images where there's comets in there. Those are my favorite subjects. So there's a cluster of stars. It'll come to me. Okay, so we've got a shot there. I think it was pretty much 1 or 2, 1.5 seconds, quite a fast ISO. And I think there I've stacked about 200 images. So that's quite a lot. But also with a wide open aperture, you can see there's no There's no spikes there, it's just round stars. But the difference between an image like this and somebody who actually does astrophotography and they spend hours in integrating a final image or collecting data, they'll have either over a period of a few days or even months or hours. It won't be as grainy, and as you can see, there's a lot of noise there. So even though I've subtracted dark frames, it's still not quite clear and quite sharp. And that's because I'm shooting at a very fast ISO. Okay. So generally speaking, you'd be shooting, if you're going to take a picture of Eta Carina over a period of a few days or weeks or whatever, you can be shooting at about 800, 640. You won't push it more than that. Here we're looking at, ISOs up to 6,400 and even faster sometimes. Yeah, absolutely.
How much would the comet start back from?
It depends on the comet. Sometimes you can, over the course of a couple of hours, or even over the course of an hour's imaging, you can see movement, and sometimes not. It just depends where it is in its orbit, in relation to where you are. Sometimes you can see movement, but you're not going to see movement like the movies and the storybooks where you have something shooting across the sky. Not with a comet. You'll see a meteor doing that, yes, for sure. 2-3 second movement, but not a comet. You're not going to see that movement. There we go. We've got a 31-second shot, 300mm lens. The ISO is quite fast. You can see it's very grainy. You can also see a little bit of lens flare there. You see that little green goblin there. Very difficult to get rid of that. That shot actually is of Antares. There's M4 there, and that's Antares. I was trying to get some of that nebulosity just below the star, but I couldn't, not with that amount of stacking time. Slightly different. I'm sure you all recognize the cluster on the right-hand side, the Pleiades in 45. And that was on one occasion when Mars made a close pass to it. But that's a few more images that were stacked, a total of about 80. Quite a fast ISO again. Yeah. That's Pleiades, M45. The seven sisters. And then on the left-hand side is Mars, yeah. And then you can see I've used an f-stop of 5.6. Again, you can see the difference there. You've got the stars looking like stars. And unfortunately, you've got Mars there looking like a star, looking like Betelgeuse or. That's something very similar. I think it was the same occasion that was Mars, when Mars was in that area, and we're looking at that grouping of stars there. That's the Hyades. See that looks like a triangle. Those stars there. And that was a little bit more, 120, a much darker part of the sky. So I needed a few more light frames to get some more stars visible. That shouldn't be there. That's Omega Centauri. Only one globular cluster that looks like that. And I think that was with telescope. I don't know how that got there. I'm going to move on. Right, and then that's the shot of the Milky Way again, much different to the first one that I took. And you can see on the left-hand side that's Mars. It's Scorpio. This is the head with Scorpion over there, and then the body goes round, and there's the tail. You just follow the cursor. So that's Scorpio. That's sort of towards the center of our galaxy. But it's interesting that even a short exposure, which was 30 seconds, will bring out the dark lanes that emanate down from Antares. That's quite cool. Okay, let's go to galaxies. Sorry, that previous shot was basically a shot of our galaxy, looking towards the center of our galaxy. That's Andromeda M31. From our vantage point down in the Western Cape or down in Cape Town, because Western Cape stretches quite far north, Andromeda doesn't rise too high above the horizon. Off the top of my head, probably about 15 degrees at some point is about the highest that you're gonna get it above the horizon. You can see in this shot there's still the trees, the tree line there. So there's a lot of haze, a lot of light pollution, even out from where we are. So that's like the best I'm going to do with a telephoto lens. But it's still nice to be able to capture it, and also you can see M32 down there as well. As I said, a lot of comments are going to feature with some of these slides. We're talking about galaxies as opposed to nebula. So you've got the small Magellan cloud on the top left-hand side there, yeah, and you've got 47 Tucana, the globular cluster, and then that was, I think it was Siding Springs, getting past Comet Siding Springs. But you can see very, very, very high ISO. That was shot with a stock Canon lens, 18 to 135 mil. It was set at 135 millimeters at 5.6, and there's 20 of those 5-second shots. But you can see lots of grain, lots of noise. Again, because we are shooting at such a high ISO.
All the comments so far have been green.
That's normal. Yeah. So, Comet Leonard, a couple of months ago, bright comet, wasn't as bright as everybody wanted it to be, was famously or infamously called the green comet, but most comets are green. But this one had to be the green comet. The media picking up. I use Deep Sky Stacker, and there's quite a few other programs in the market. And that gives you an idea. Sometimes, especially we all from the Cape, you know what the wind can do. Sometimes I've got to shoot from indoors. It's outside my bedroom window while Sarah's sleeping and I'm taking shots of comets. It just gives you an idea what you can do. That's a standard setup: tripod, telephoto lens, out the window, away from the wind, and take images. Yes.
Looks the same point to the window.
Yes.
That glass in that window?
No. The window panes are, yeah, the windows are actually open. You can see them just over there. There's just a burglar bulge, yeah, through the burglar bulge. That's a shot of Venus, which is going back to planets now. That's a shot of Venus and Jupiter. I think it must have been some conjunction. And you can quite nicely see at least 3-4 moons there. Yeah. 4 Galilean moons. And again, a short exposure time, so I don't get too much star trails, but that high ISO 6400, that's a lot of noise. That's Venus again. You can see the difference with the 8-second exposure. The previous shot was just over a second and a half, so 1.5 seconds. There's 8 seconds. Look at the cloud movement, the blurriness, and the trees. Venus still looks reasonably round, but everything else around it is definitely blurred. Okay, so that just gives you an idea of shooting with longer exposure times and what it does to your landscape and to your... No, everything's on a tripod. On a tripod. If it was the tracker, I'd have Venus pinpoint 8-second shot. I'd have very, very a clear pinpoint of Venus. The movement that you see from the clouds, or possibly wind, as well as the trees. But that movement, that 8-second movement, is there regardless of when, or it could have been a reasonably still day. You'll still get that cloud moving slightly that the camera or the sensor has picked up, because the exposure time has been as long as 8 seconds. Yeah, another big thing with shooting nebula and galaxies and anything other than the moon or planets is a lot of all your stock cameras filter out infrared light. Okay, you can convert the camera. It's not a expensive. It's not very expensive to do so. I think Orms and Cape Town will do it, where they take the IR filter out, and basically what that helps is you collect a lot more hydrogen alpha light, which all these nebulas, galaxies have. So you'll get a lot more gaseous cloud in your image. These pictures that you've seen, the filter has been on there, but Canon came out with the Canon DA 30 or 60 DA, they called it DA, specifically for astronomy use, that had a couple of mods. You can do that. You can do those mods, and that does help. If you're going to sort of get a bit more involved in the subject, you can do that. It's not a big cost. I haven't, but yeah, that's okay. So here's something that's also quite interesting in terms of taking images that last for a little bit longer than a second or so, and also when stacking them and you trying to stop that or control that graininess, that noise that you have with those light frames. Okay, so there's a couple of ways of doing it. You can shoot dark frames. They call them dark frames because you basically cover the lens of the camera, and you shoot those dark frames at the same settings that you shot the light frame. So if you're shooting, say, at 1 second and 500 ISO, and you took 100 of them, you'll take 10 or 20 the same settings, but with a lens cover on. Okay. And those are dark frames. What you'll do then is you'll subtract, or the program will subtract the dark frame from the light frames that you've taken, and any noise due to temperature will be subtracted from your light frame. That's the programs do it quite easily, quite readily. It's a way of subtracting noise from your original, from your light frames. It does work, absolutely. Something to keep in mind. If you're going to take 5 shots, it's not a big thing. 10 shots. If you start looking at 50, 100 shots, light shots, then yeah, it does. It certainly helps to take dark frames, as well as taking bias frames. Bias frames are pretty much the same as dark frames. So your chip, your sensor, when it's manufactured, has some sort of noise that's inherent with its manufacture. Taking bias frames subtracts that noise. If you take dark frames, you don't have to worry about bias frames. You just take the dark frames, but the dark frames will also subtract the inherent noise that the sensor has. So yeah, it does help. It does help. Pierre asked me just now what program I use to stack. So I use Deep Sky Stacker. So you load 50 light frames or 100 light frames on it, and then you load 10 or 20 dark frames, and the program will actually make one master dark frame and use that to subtract whatever noise those light frames have taken. Flat frames, all intents and purposes for this type of photography, I don't use, but flat frames are quite handy if you have a lot of vignetting in your image. So I'll show you a couple of examples just now. A flat frame will subtract any, not noise, any dust spots or artifacts in your focusing train. So if you take a picture with lots of black spots and white spots and whatever, if you take a flat frame, it'll subtract that noise from your original light frame. And the way you do that is you can point it at the sky. I use the laptop. I just bring the camera, the lens up to a white page on Word, and I just take a few shots, and I use those flat frames as well in deep sky stacker. But for the photography that we're talking about, just the tripod and the camera, you don't need to go to those lenses. It does help to make your image a little bit better at the end, but it's not crucial. The important thing to remember is that your dark frames have to be taken at the same settings that your light frames were taken, same settings and the same temperature. So you've got to take them pretty much after you've taken your light frames. Your flats and your bars don't matter. They can be taken at any temperature, and the temperature is not important. Your flat frames, just quickly, also slightly different. You basically letting the camera work out an exposure. So you shoot on aperture priority, and the camera will work out an exposure where your graph, your histogram, thank you, Pierre, your histogram is pretty much in the middle. So you just play around with the shutter speed or the aperture until the histogram's in the middle, and you shoot off plenty of those and observe. It's slightly different to shooting darks and bars. Yeah, those are some of the programs that you can use. Deep Sky Stacker, Cirrus, Equator. Those are all freeware. They don't cost anything. You can download them. PixInsight and Star Stacks and Registacks you have to buy the programs. I must admit, I haven't used anything but DSS. It's been fine for what I do. It's also a preference. There's also quite a huge learning curve. So once you're happy with something, like I am with DSS, I'm not going to move on. You'll recognize the landscape. It's a shot of Hermanus from the other side, from Kansbay side. Let's walk the bay. I was looking for a comet, and all I could find was Venus. Right, and then you've all heard of the Big Five of the African sky. Sure you have. Great stuff. Okay, so we've got a competition. ASSA's got a competition on at the moment. You can you can go onto the website and get a bit more information. You can submit your images, which are basically the Big Five of the South African sky. It's the Milky Way, the Southern Pleiades, Coal-Sack Nebula, Omega Centauri, and Eta Carina. Those are the 5 targets that you're looking at. Over and above that, if you submit those images, forgetting about the competition, you'll also receive a mug, a coffee mug that says Big Five on it. You just need to put together a couple of words, just explaining how you took those pictures, what you were looking at, etc., etc. So that's a competition. Well, not a competition. There was an initiative years back. Aki and I started it off. Well, I forget the year, and we spent quite a lot of time putting it together and deciding on the targets. The Big Five of the African sky was the original slogan, the original wording that we came up with, but it took us a long time to work out which targets we were gonna actually pick to portray the Big Five of the South African sky. So yeah, if you want to start off with that, it's actually quite a nice way of learning your way around that part of the sky. You've got the Milky Way. All the other targets are very, very close to the Southern Cross and Crooks. Southern Pleiades is there, Colsac is there, Omega is not far away, as is Eta Carina. And that just tells you more about the competition. If you go onto the website, you'll get quite a bit more info, as well as where to submit the images and what format they want them to be in. You've got up until the end of the month. So hopefully the clear sky is the next week and a half. All right. I mean, are there any, at this point, are there any questions, anything that you'd like to ask me, or something else that you'd like me to cover regarding using a tripod and a camera?
Just say that it's compared to tracking on. Or do you do more?
So I probably half. Yeah, half. I don't. So when I do track, it's not. I won't push it more than 30 seconds, sometimes a minute. So a lot of the pictures that I haven't shown you that I'll get to have been with telescopes that are go-to telescopes on tracking mounts, but a lot of them have been Altaz mounts, so you're not getting that equatorial tracking, the radar session tracking. So most of the exposures have been 30 seconds, sometimes a minute. At the moment, the last couple of years, I've got a EQ5 mount, it's an equatorial mount. So I've pushed the exposures up to about 60 seconds, sometimes a little bit more, but no guarding. And the alignment is just basically south 3.3 star alignment, and that's it. So you can't really do much longer than that. As I said, I'm not big on the actual astrophotography, collecting data for hours on end or days or weeks for a final image. So I don't do that. I prefer quick and easy, and especially with comments. Yeah.
What's the point? Trying to sort out 3-5. Out of 5 types of objects you get in the night sky, they are close to each other. Actually, can't, off the top of my head, think of alternatives to those 5, but they're very close to each other.
We had probably won't be able to remember, but I think we had about a good 15 targets that were all amazing, only seen from sort of circumpolar and close to south circumpolar stars. And we had about 15 targets, and we narrowed it down to 5. But I don't know, there were a couple of targets there that didn't make the grade. But yeah. Well, exactly. I mean, you're looking at galaxies. The 2 clouds are notorious southern hemisphere targets, 47 TAC. But you can't, again, we are pretty spoiled with the 2 best globular clusters visible within the northern hemispheres. You know, southern hemisphere has got both of them. So which one do you pick, 47 TAC or Omega? You have to go for Omega. Yeah. And it also had to be pretty much specific. I mean, there are other open clusters very similar to the Southern Pleiades that are visible, especially on the celestial equator from M45. I mean, we see that but it had to be specific, a South African, a Southern Hemisphere. Yeah. So most of them are either from Louis Trichardt when we lived up there, or from Pearly Beach. I've traveled a little bit, but I would say that 90% of the images were taken from home. Yeah. Pearly Beach or Louis Trichardt, yeah. Just questions pertaining to photography and what equipment to use and whatever that is. All right, just so quickly. I mean, Second part of the presentation was basically my journey, the last 3-4 decades. I've actually been quite lucky to witness quite a few astronomical events, from occultations to conjunctions to meteor showers to NEOs, fireballs. A lot of them have been clouded out as well, as you can imagine. And that's me holding my head. No, baby, the clouds. We were waiting for quite a big event. It was a pass of Tim and I were actually waiting for a pass of a NEO shortly after sunset, and everything was set up all ready for it. And as you can see, there was absolutely no way we were going to catch anything with all that cloud around. NEO, near-Earth object, like an asteroid. And through the years, I've done quite a few talks, either on TV or been involved with radio interviews, Cape Talk, Times Live. I did an interview with ENCA years back, and it was the middle of the winter, and we were looking at, it was a meteor shower. They interviewed me about a meteor shower, and towards the end of the interview, we were talking about how cold the weather was and how difficult it was going to be observing the shower at 3 o'clock in the morning in sub-zero temperatures. And I said, well, you can do that with a bottle of Old Brown or a couple of shots of Old Brown. And then I realized you can't advertise Old Brown on TV without. So yeah, there was actually quite a funny moment. The commentator afterwards, the interviewer said, listen. I said, yeah, I realized that. Anyway, I've also had I got the nod when President Obama did a stargazing event at the White House, and I did a live feed from Louis Trichardt to the White House that evening, showing them Omega Centauri, Eta Carina. So that was actually quite a lot of fun. But over and above that, I've had quite a few successes with NEOs, with near-Earth objects, and asteroids. The picture that you saw before that was really, it was an event. I think it was BL86. It was three lunar distance, or just over 3 lunar distance away. So it was quite close, quite bright. I've also had the opportunity of setting up 2 telescopes where I can actually view, so I can get a chance to actually see the object as well as image it. I'm not going to go too in depth with what you're looking at, but yeah. So that was asteroid 2004 BL86 that came past. I've also been lucky. We've been lucky. We've had the opportunity to observe 2 trances of Venus in one lifetime. That's really. Venus? It was Venus? Venus. Yes, Venus. So that was in 2004. We got, it was 2004. And the next one, that was the first bit of outreach we did. The next one was 2012, June 2012. And then the next transit of Venus is on the 11th of December 2117. So there's no way I'll make it to 3. So yeah, two transits of Venus is quite cool. Yeah. And then we, on the outreach, as Pierre rightly pointed out, when I say it wasn't really Sarah was very involved in all the outreach, from setting up to putting material together, proofreading. And the boys, Chris and James, used to drag them along to hand out pamphlets and help them carry things and whatever. So just quickly, we've had 2 International Astronomy Union grants. The first one was for the Year of Astronomy in 2009, followed by one a couple of years later. And then we've done National Science Week with SASTA 7 years at a trot. Just going to run through a couple of picks. We've reached hundreds, thousands of kids, adults, all those years. We've done a lot of Earth hours and International Observer of the Moon nights. Unfortunately, this has come to a bit of a standstill after I moved to Pearly, and the weather has a lot to play for it. So I've organized stargazing evenings out in Pearly on the Village Green, and half the time we've had to cancel it because of weather. I've got an observatory at home that I have the use of, so it's become easier now. I can set up, I don't have to worry about setting up equipment, and I quite often advertise stargazing evenings. But up north, 80% of the time you're going to have clear skies. Down here, it's the opposite way around, but it's still a nice part of the country to live in. That's a very, very young Christopher and James. Standard now. And that's just a little clip I put together years back. It was at the Letaba show. We were looking at Saturn. And when I say thousands of visitors, I mean 3 days at a show like that, we'd push 2,000-3,000 people quite easily, looking at the sun during the day, handing out information, and then in the evenings, looking at either projecting onto a big screen some of the brighter nebula and planets, or looking through the telescope. And that was probably around about this time. It's now winter, the top of show, so you can see we dress quite warmly. There was another asteroid pass. And then I've been fortunate to be invited by a lodge in Sossusvlei Desert Lodge. Years back, and I spent, I think it was 4 weeks initially, over December, late December, January. I went up and then Sarah joined me, and I ran the astronomy program up there, and then subsequently have been back a few times. I'm dying for them to give me a shot again to go spend some time up there. Beautiful part of the world, really special place for me. And the stargazing is just out of this world. That is the picture of that's the observatory, the lodge. That's the setup. They've got a 12-inch mead with an office and then the observatory. It's permanently out there covered. We don't take it in, but it's a beautiful, beautiful part of the world. And I think the first time we were there, it was New Year's Day, Sarah, yeah. And we had a couple of dust storms come through, and then about an hour of rain. I think it was about 5 or 6 more over a period of about half an hour. And that was it. That's the rain for the year. And those dust storms were just unbelievable. Sounds good. There we go. That's the lodge. That's the lodge from Europeans.
Yeah, it's like also very simple. And that is like United States Air Force pilots and all sorts of guys.
Just generally unidentified flying objects, just generally. Yeah. So in all the years, the 7-8 years that I was observing director, a lot of the, in actual fact, most of the UFO sightings and any sightings used to come to myself, and there were between Tim, Cooper, and Greg, and a couple of other experts. We used to sit down and sift through the information and find out and try to explain to them what they were looking at or seeing. Most of the times we could pinpoint what they were looking at, either a fuel dump from a rocket or a meteor or a Chinese lantern or whatever. So 99.9999% of the time, it's something that we can understand. That unidentified part. Now, I've never seen anything that I couldn't identify. The other day we had actually not the other day, we had a sighting a couple of weeks back, fireball, and it made me think of the times I would sit with a few people looking at stars and whatever, and we'd see something real low down on the horizon. In this particular case, it was a star Arcturus, and somebody said to me, "Oh, look, there's a low-flying airplane." And honestly, you could see a green and a red light. I kid you not. So I looked at it. I said, "I know it's not an airplane. I know it's a star." This guy, through binoculars and with the naked eye, was convinced. Him and his friend were convinced it was a star. So I swung the telescope. It was an airplane. I swung the telescope around, and you could clearly see it was a star. So atmospheric phenomena or conditions at the time create visual effects that sometimes we can't explain. Okay, but more often than not, it's something quite. It's not a UFO. It's not aliens or. But
seriously, special task force into it. Is that true or not?
I'm out of touch. I'm out of touch with that. But I would probably guess that they're more concerned about China and than anything else. But we've had. I mean, it's been a roller coaster ride regarding reports of people being adamant they've seen these three lights and the lights have done this and that, whatever. What are we looking at? And is it aliens? And is it this? And I guarantee you, it's some chopper. 2 choppers flying around, cloud, whatever, and but interesting. Yeah. So we had a report a couple of weeks ago. Tim's dealing with it now. I got a lot of reports on Facebook from the club's page and just generally social media, and there were a couple of people who were adamant that what they saw was Venus. And Venus at the moment is quite prominent setting in the West. And even when you say that, listen, if it's not moving, okay, then you're correct, it's Venus. But if you're seeing this thing for 2 or 3 seconds, there's no cloud around, there's no way it can be Venus. Because it's moved very, very quickly. It's disappeared after a couple of seconds. So you did see a shooting star. I know, it was Venus. Opposite. Can't argue with him. So just a few pictures of Sossusvlei and the setup. Really, really great part of the world. Fantastic part of the world. Some of these pictures are serious, by the way. Take the.
What kind of dust to be?
Yeah. Not at all. Not at all. It's beautiful. It's I'd love to see Sossusvlei with water. That would be really, really amazing.
Yeah. 2 years in succession, 1 year.
Yeah.
And the next year,
So that was really, really clear. This is also an NEO, and you can see that's Cat's or Nebula down on the bottom right. So this is what I'm saying with that IR filter cut out or taken away from the camera. You'll get a lot of that nebulosity, that hydrogen alpha coming through if the camera was modified. I mean, this is standard stock camera with no modification. I'm not too sure if you can actually see that. Yeah, there we go. Okay. That was shot. That was in the air coming past from Pearly Beach. It actually looks like a satellite, but it's not. And there's just the same shot, just different processing, just to bring out a bit more of the nebulosity around the cat's paw. Sorry, well past the atmosphere. So we'll be looking at most of these NEOs are most of them are at least 2 to 3 lunar distances away from us, but that's pretty close. That's pretty close. And the NEOs, they're classed as NEOs because they have Earth crossing orbits, or potential Earth crossing orbits. So they're quite hazardous. I'm just going to run through it. Yeah, that was Makhado. I mean, that was a comet. Again, huge tail, 30, 40 degrees. You can see there's the Magellan cloud there. But I mean, that tail rose about 40 degrees above the horizon. It also went off to the west by about 40 degrees. And when the nucleus disappeared below our horizon, people north of the equator could still see that tail. But you didn't see it streak across the sky, as we discussed earlier on. It was still pretty, it wasn't that dynamic. Those are just some shots. Also, this is all tripod shots that I've put on. You can see that's 55 mil camera, 20 seconds. That's why you've got lots and lots of movement of stars there. Excuse me. Sorry. Ten-second shot with a 300 mm lens, and you can see what it does to the star movements. That was an eclipse a couple of years back. That's Mars, just past above the tree line with the Pleiades at the bottom. That's just one shot, 30 seconds at 6,400, but very, very low above the horizon. Crescent Moon and Venus over here. That's a nice long exposure, 30 seconds, and I've stopped the sky was so bright, I actually closed the lens down quite a bit. That's f9, aperture of f9. It was taken a couple of months back. That's a meteor, and Tim identified it as a gamma normid. Sorry? Gamma normid. That's a stack of about 50 10-second shots with a 200 mm lens. And you can see wide open, there's no diffraction spikes on the stars, but lots of nebulosity. That's M42, and then that's the belt, the 3 stars making up the belt of Orion, Flame Nebula, and of course the famous Horsehead. Sorry? Yeah, those are. So that red color that's hydrogen alpha. That's there. But the green glow, are you talking about the green glow here? Yeah, that's just basically the lack of enough dark frames. and trying to a very, very high ISO, trying to get as much light as you can, and you end up with an image that's a little bit oversaturated like that.
You're finding those new satellites that Elon Musk has put out, are they messing you around, taking any photographs?
Don't talk to me about Elon Musk in the satellites. That's a sore point. This was taken last year, Comet Leonard. 9 frames, 6 seconds. Again, you can see lots of movement with the stars, but I wasn't worried about that. I just wanted to get the comet coming through the cloud there. I'm interested in that. And a lot of the photography that I do is but it's really nice to have a comet, something that's a bit more dynamic in the image with deep sky objects. So I've got a comet here, Atlas, with the 3 stars of Orion's belt, with the Horsehead Nebula. So that's what I enjoy more than centering on the Horsehead Nebula and taking 2-3 hours. So I like the more dynamic stuff, like the comets and the conjunctions, and it's my preference. There's I forget which it was. Yeah, G2 Master. It was the second South African comet discovered from Sutherland 2 years back, 2015, passing next to the Helix Nebula. And I was waiting for that shot. I mean, I knew this was going to happen, and if I'd got clouded out on that night, I think I would have slit my wrists. Yeah, exactly. I mean, again, a little fuzzball, little comet there, just over there, passing M83, the Close-on Galaxy. All right, so I'm not going to bore you anymore. I'll just carry on. The last eclipse, lunar eclipse. Yeah. That was Nova 1987, I think. If you ever get a chance to look at M46, I think it's about 43 degrees above the horizon at the moment in Canis Major. It's an open cluster of stars, but embedded in the, well, embedded is actually quite a lot further away, is a nice planetary nebula. You can see it there, and you can see it in binoculars. It's quite a cool object to see. Sun. That's seen these. Sorry, I'm just going through. That's Saturn. Just a few more outreach pictures. So we did quite that first outreach in 2009 that we got involved in, sort of paved the way for us to do a lot of outreach using live feeds. Not either, but with a camera attached to a telescope, and then eventually we'd feed that through YouTube, so you could go online and actually look at the event. And that was really fun astronomy, having groups of people looking at a big screen at what the telescope was saying. And we used to try have 2 scopes set up, because there is nothing nicer than actually visually being able to see at the eyepiece the rings of Saturn or the moons of Jupiter, as opposed to a big screen. But it was also so fantastic to be able to show it to a big group. For example, and then just last but not least, Comet Silent Springs. I don't know if you remember that a couple of years back, 2013 01 Silent Springs. over a period of about 2-3 months, we followed this comet, and it made a close pass to both the Large Magellan and the Small Magellan Cloud, past 47 TAC as well. The big thing with this one was that it was going to get very, very close, and the tail, or parts of the tail, would enter Mars's atmosphere. So scientists wanted to study what would happen, and so it was quite a big pro-amateur collaboration with a lot of astronomers or amateur astronomers who were photographing Siding Springs. I managed to get it just before it actually disappeared in Mars's atmosphere, and quite a few of my images prior to this, as well as this, were used by NASA in their presentations to the public and to the press. It was actually quite a fun time. Sorry? This one here, or that, I guess. Yeah, that was through a telescope. That was through a telescope. All right, folks. That brings me to the end. Just one thing: if you do have very sensitive equipment and telescopes, and please look after them, especially in our conditions with moisture and dust and whatever. So if you do have equipment that's very delicate, please look after it, like I'll do with mine. And on that note, thank you very much. Yeah, you know how to shut this down. Thank you very much.
All right, thanks very much. It was a fantastic talk, and I'm sure everybody enjoyed it. And hopefully, as we use this venue more, we'll be able to attract more people. We're looking at sharpening up our advertising. I'm sure you could even give us some tips on that.
But the venue is very nice.
Yeah, I'd just like to stop the recording.
Yes.